Hi, Dan Abbott. This is lesson 7 in the series for CAD Management, AEDD260 at Southern Maine Community College, and this is going to be our introduction to AutoLISP programming. This is one of the most powerful tools available to you in any CAD program, short of learning how to use some of the more sophisticated applications like C# or VBA. But the beauty of this AutoLISP programming language is that it incorporates all of the AutoCAD commands into the language itself, so that a serious AutoCAD user already knows much of what you need to know in order to write programs in. I'm going to go through the background, go through the syntax, go through all kinds of stuff with the programming language. But before I do, I just want to set your mind at ease when it comes to being worried about programming and show you how simple and useful it is to write AutoLISP programs. We'll go over and look at AutoCAD. So if I come down to the bottom and I go and look at my object snaps and how they're currently set, you can see that at the moment I have them rather unusefully set to almost everything. Now I doubt that you'd ever do this, but I'm going to point out that most of us have a certain group of object snaps, running object snaps, we like to have running all the time. And it's also possible that you might want situations where you have just one or two specifically set for a particular application. So what I'm going to do is to go through and say, let me just select the ones I want. So I don't want geometric center, I do want intersection. I absolutely want extension, not insertion point. Although, I don't usually leave that running. Perpendicular, absolutely not. Tangent, absolutely not. They would just be showing up all the time. Nearest, the worst that you could possibly set, because that would mean that every time you went near something, the only object snap it would find would be the thing nearest to where you just selected. I do like apparent intersection, however. So I now have center as well. So endpoint, midpoint, center, intersection, extension, and apparent intersection. Those are the object snaps that I want running most of the time. Well, if I do change that, I'd like to be able to go back, and I can go back doing what I just did. But I'm going to be looking at a variable, and the variable is called osmode. And if I type it, 6183 is the value identified with osmode right now. I'm going to explain what that means, but in a second I'm going to explain what that means in a bit. But all you need to know for now is that that number will give you the OSNAPs that you want. So let me set that to 1 now. I'll go back and you'll discover I have a single object snap set in its endpoint, the very first one. So now if I went back to the command prompt and I typed osmode and set it to 6183, then I went back down here. Those are all the ones that I want set. So what is osmode? Osmode is what is known as a system variable, sometimes called a Setvar. And a variable, obviously, is simply something that changes in value. It can be changed by either AutoCAD doing something in the normal course of your operating it. You change system variables whenever you go into a dialog box and change a value of some kind there. I showed you that when we came down here. When I was selecting those items, I was changing the value of the system variable called osmode. Osmode, the system variable, means it is part of the AutoCAD system structure. It's saved. Well, let me show you where it is saved. I was about to type that in. But one of the things that comes up sometimes is you're wondering where these variables are saved. Some of them are saved in the drawing, some of them are saved in environmental variables, and some of them are saved in the system registry. There's a very nice Express tool in AutoCAD. And that Express tool is called Alias Edit. Nope, I'm sorry, it's not. It's called System Variables. Sorry, I was on the wrong lecture. So if I came down here and said, where is osmode saved? I just got to find it. And it is right there. It's going to tell me over here, my current value right now is 6183 because that's what I have it set for. The initial value is 4133. And it's saved in the registry, which means once you set it, it's saved across all the drawings that you're in. So it's not something that you have to save differently for every drawing. Down here, it shows you what the bit code values are for each of the running object snaps. And this is a key thing in terms of understanding where that number came from. Computers use this bit code or bit sum process for keeping track of lists, and it does it for a reason. If you have a list where it's possible to have more than one item on the list active at the same time, in order to identify which of those items there are, a computer works best if it has a value, a number associated with each of those individual values that can then be added together to come up with a single sum, the bit sum. And the only problem with that is if you start numbering things like 1, 2, 3, 4, 5, if you say, well, I want number 1 and number 2, well, to add them together, that's 3. Well, you already have a 3, so now there's a conflict. So what computers do is they use the following kind of numbering system. First item is was given the value 1. Second is given the value 2, then 4, then 8, then 16, then 32, then 64, all the way down. The reason for this is if you identify every item in a list with that number and that kind of number, any 2, 3, 4, 5, 6, 7, or any other number of these that you want to include as being active at the same time can be identified by adding up those values, and you only get one unique sum when you're done. There's no way to get a value any other way than to add them in a certain way. So if we went back to, okay, so what they show you over here is, and the reason I know, and 0 means none, by the way. I mean, 0 just turns it off. First thing is endpoint. That's the most common of the object snaps. It's given the number 1. So if you set Osmode to 1, you're going to have a running object snap just of end, or endpoint. The second one is mid. So if you have a value of 2, it's set only to midpoint, and a value of 3 is set to endpoint and midpoint because you've added those two values together. Now you then go to center for 4, 8, 16, and if you notice going all the way down through, they just keep doubling and doubling and doubling until they get to 16,384, which suppresses the current running object snaps, which seems a little odd, but it's possible for you as you're working to say, I don't want those object snaps to be active at all right now, and you can temporarily suppress them. Now you would never do that by typing 16,384 in Osmode, but internally that's how the software keeps track of what your intention is for that. So the largest value is 8192, and that's the parallel. So all I did when I put my check marks beside that is told AutoCAD to go and add the values of each of those things that I've selected to one unique value, and that one unique value is 6183. Now that's how variables work. There are hundreds and hundreds of variables in AutoCAD. This is a unit on AutoLISP, so, and before I get you to that first command you're going to create, I just want you to understand what we're doing. In AutoLISP, there's a function called Setvar that allows you to set a variable in AutoLISP, and the format for doing that would be to say Setvar quote Osmode close quote, and then whatever number you wanted to put in there. So let's just say I wanted to have the running object snap set to just endpoint. I put a 1 here, and that's the way I would write the code. When I was done, Osmode would be set to 1. Alright, now, so start to finish, this is how I would write a program that would set my object snaps to my default preferred setting. I come down here, I go and I select each of the individual object snap settings that I want as a running object snap. So endpoint, midpoint, center, intersection, extension, and apparent intersection. I would then check at the command line to see what value was assigned to Osmode, the variable. That's 6183. Then I would write my code. Now I could do that at the command prompt, which I'm going to do. I could say I want to define defun as a function in AutoLISP, a new function that behaves as an AutoCAD command. C: means AutoCAD command. I'll call it OO because that makes sense to me. I need an open and close parenthesis for reasons that we can talk about later. And what will happen when I type OO is that AutoCAD will then do a setvar. In other words, it will set a variable equal to the value that I give it. The variable name is osmode. It has to be in quotes because it's in, say, string. And 6183 is the value I want to assign. I need one more parenthesis, which I know because I have an opening parenthesis at the beginning. And I'm going to press enter, and it returns C:00. Now if I were to go down to my running object snaps, and under my running object snaps I go ahead and clear them all, or select all of them. Let's select all of them. So I just selected all of them, which means the osmode setting is 16,383, big number. If I would never use all of them, by the way, because they'd be getting in each other's way. But if I type 00 right now, it returns 6183 because it reset osmode only to my favorite settings. If I go back and clear everything, so I have no object snap setting at all, and I type 00, it does the same thing. So if I'm drawing along and I'm doing something where for whatever reason I want to change my object snaps that are running and say, you know what I want is tangent and endpoint. So I want tangent and endpoint so that I can say go from the endpoint of this line tangent to this arc. If I have a bunch of those that I want to do for whatever reason, I can have a running object snap collection that works for me. In that case, you know, I can go back in here and trim. So obviously what I'm doing is making shapes like that. And when I'm all done, type 00 and I go back to my favorite running object snap. So now if I want to go to the midpoint of something and then go to the center of something down here, I've still got the running object snaps that I want. Now that's fine, but I'm not going to be typing that in every time I want to use that command. And that command right now is in random access memory. The minute I get out of this drawing, that is gone. So what I'm going to do is to go and type it into a text editor, which is a code editor right in this case, called VLISP. I could do this in Notepad, but Notepad is black and white. VLISP is a code editor, which means it has some tools that we don't have in a normal text editor. VLISP brings up the VLID tool. Now, when you first install AutoCAD, when you type VLISP, you're going to be asked what you want to do. Do you want to use VLISP, or do you want to use the new Microsoft called Microsoft Code, Visual Code, I think? At any rate, it's not VLISP, and you do not want to use it. I've had so much trouble trying to use it. It was put into AutoCAD 2021, and it has caused me more problems than attempting to make it work. So don't use it. We'll get it worked out. There's some glitches there. So what I'm going to do is go and say, let's make a new file. And that new file, I'll give it a name. I'll just call it Dan's AutoLISP for now. And then I'll usually have a little bit of other header material. Like the script, if you use a semicolon, it means ignore this line. Unlike a script, you can have blank lines, however. So I'll just say this is my object snap default default settings. So what I'm going to do is write that code again. Now, because I wrote it at the command prompt, I could go back and copy it. But I'm going to retype it here because I want to talk about it as I do. But if I did something at the command line and said, oh, I really like that, I could have copied it and brought it over. The fact is, I used to do all kinds of test stuff at the command line, but almost never anymore, because the value of VLISP is so high in these tools. Starting with the fact that every AutoLISP program begins with an open parenthesis. The open parenthesis will be read in this text editor. Then you have to have immediately following it a Lisp function. A Lisp function is predefined by VLISP, and if you use a Lisp function, as you're typing it's black right up until you add the very last letter. Defun is the name of the function, and it simply stands for defined function. So you do have to learn some new functions in order for AutoLISP to work for you. But there's kind of a nice thing about it is that AutoCAD commands are also available to you as well as variables. In order to write a new function that behaves like other AutoCAD commands, you have to say, treat it like a command. You put a C:" in front of the function name, and now it doesn't have anything to do with the drive letter. It's not C:" as a C drive. It is simply command. Now what follows, the name of your command, After that, you have an open and a closed parenthesis. Sometimes something's inside, sometimes there isn't. For now, there's no reason to put anything in here, and I'm going to press the Enter key, unlike the command line where everything was stretched out. What I want to tell AutoLISP is this: when I type 00 at the AutoCAD command prompt, do the following. Setvar, set the variable, osmode, name of the variable, equal to 6183, which is the value that I want to assign to it. Now you'll notice that red is used to identify parentheses, blue is used to identify Lisp functions, black is used to identify anything that I have made up. C:00 is not a Lisp function, it's something that I'm defining. Magenta is used whenever you're showing something that is a string. There's quotes around it. And in this case, we have an integer, and an integer is always given the color green. It's not every number that's green, it's only integers. If it was a real number, i.e. a number that can be smaller than 1 or have increments that are less than 1, it would be teal colored. Now looks like I'm done, except that just like in math, if I have an open parenthesis, I need to have a closing parenthesis as well. And one way to find that out is if I double click at the end of this, it shows me where that one is closed. It shows me that one is closed, and I realize if I came up here and tried it going the other way, I can't find where that one's closed because it isn't. So I need one more. What I'm going to do is press the Enter key and then type it in, and if you watch the cursor, that flashing cursor right there, watch what it does when I type in the closing parenthesis, and it'll jump to the open parenthesis that it is closing. That is really helpful as you're writing these programs. Now there's my program. One thing I can do with this is say let's format it, and this isn't going to change very much, but I'm going to pick the format tool here, and it does one kind of fairly subtle thing. It lines up those parentheses, which makes it easier to troubleshoot later on. Now I want to check this. I can double click on it. I'm double clicking here just to highlight the entire program. I can go up here and say check what I've just highlighted. I do that, check is done. That's the no news is good news function of Lisp programming. In other words, it didn't give me an error, so far it looks good. Doesn't mean it'll work, but it does mean the syntax is correct. Now I'm going to highlight it again, and these buttons up here, that's the most useful of all your toolbars right here. Those buttons right there are the ones you're going to use most of the time. I'll put it back here. I just wanted to kind of show you what it looked like. Alright, so now that button loads the entire window. If I had 125 Lisp programs and I picked that button, it would load all of them. That loads only what I've highlighted, which is what I normally do. That checks the entire thing, checks only what I've highlighted, formats the entire thing, formats only what I've highlighted, and then there's a couple ways to just pick a bunch of things and just comment them out. So for instance, if I was working on that but I decided, no, I don't want that loaded, if I did this, it adds those semicolons, which means the program would have no function at all. I go back here and say, well, let's get rid of them now. Now it goes back to being Lisp code. So that's my whole program. So I'm going to double click it. I'm now going to load it. I'm going to come back out here. When I come back out here, I'll try again to do the clearing of all the object snaps. So I've cleared them. I'll go and start a brand new program. The brand new program, I don't actually have 00 anymore, because when I change drawings, when I say brand new program, brand new drawing is what I meant. When I change drawings, anything that's in memory goes away. So now I'm going to load it in this drawing. I go back in. My Lisp functions right here are set to endpoint, midpoint, center, quadrant, intersection, extension. Those are the standards. Now if I type 00, 6183 is returned. I come back here and now I have my own favorite all set up for me. So we can write them at the command prompt, then they go away. You can write them in VLisp, then you have to load them, or you can put them in a file called the ACAD.doc.lsp file and put that file in the support directory, the support path for AutoCAD. That's what you're going to do. You're going to create an ACAD.doc.lsp file, You're going to give it to me 3 times. The first one's going to be some fundamental, fairly basic commands you're going to write. And and you're going to write them and figure out what they're going to be. I've got some guidelines for you, but I'm not giving you specific requirements. This is not an exercise. This is, I want you thinking, what could I do? What could I automate in AutoCAD that would be helpful to me? And then write programs that'll do that. And you're going to have to do a certain number of them. And again, the details for that will be in Brightspace. So if I want this to load every single time I start AutoCAD, what I have to do is to put it in a file called ACADDoc.lsp. So I come back over here, and I'm just sort of starting this thing up. What I'm going to do is to, before I do that actually, I'm going to go and make a folder to put everything in. So I'm going to go to my C drive. In my C drive, I've got a folder called Dan. And I'm going to go in that folder called Dan, and I'm going to make a new folder. And that new folder, I'm just going to call AutoCAD Support. Okay. Now, when I go back to AutoCAD, I can save this file. And I'm going to save it, and I'm going to put it on the C drive in the folder called Dan, in the folder called AutoCAD Support. And I'm going to give it the name ACADDoc.lsp. Now, will that do anything? Well, it will, but it will only do something if AutoCAD can find it. So now I'm going to go back to AutoCAD, and I'm going to tell AutoCAD where to look for support files. Now, we covered that in an earlier lecture, and that's the options command. So I'm going to go to options. But before I make a change, I'm going to go over here to profiles, which is the last tab. I'm going to start over here, but first I want a new profile. So I'm going to make a new profile, add to list, and I'm going to call this one my Lisp class profile. Apply and close, go down and pick it, make it current. Now I'm going to go to files, and I'm going to change my support directory. I'm going to tell AutoCAD, no, don't look here anymore, which is where I was looking. Instead, what I want to do is go and look in fact, I'll tell you what, let's put a new one in here. I'm going to put a new one in here. Oop, went to the wrong spot. Go back to options, go back to files. Did I save that? Yeah, Lisp class. So go back to files, go back to support. So right here I'm going to add a new support file, and I can go to the browse button to find it, or I can type it in. I'm going to go to the C drive. I'm going to go to Dan, AutoCAD support, and say that's where I want AutoCAD to look. Now this one up here, I'm going to remove it. This one down here, I'm going to make it number 1. I'm going to say the first place you look for anything you're looking for, look in that folder right there. I'm going to apply it, and I'm going to pick OK. Now, I'm going to start a new drawing. And when I start the new drawing, go over here like this, it's going to ask me, do you want to load that program that we just found? This is something AutoCAD does to prevent you from accidentally locating malicious code. I wrote this, so I'm perfectly happy with it, but it's looking for it and saying, well, that's where it is, that's what it's called. Do you want us to load it, or is it maybe something you don't want to load? I'm going to say always load it. And just so I don't get that annoying question anymore, although always load should get rid of it, over here under trusted locations, I can come down here and add as a trusted location the same location. I can go right here in AutoCAD support, say make that a trusted location, which means AutoCAD will stop bothering me about it if I put new stuff in there that it wants to load. Now, come over here and look and see what the current settings are, and they're the same as I had before, because when I changed that value, it's saved in the registry. But I didn't load OO into this drawing directly. However, OO is now a command, and anything I put in the ACAD.lsp file will be automatically located. If I'm using this profile, it'll be automatically located every time. So now, that's how easy it is to write a useful program. And if we'd been in a lab, I would simply have walked you through that at the beginning, had you press enter and say, congratulations, you're a programmer. Now let's take a look at some of the background information and take a look at how you can now gradually build more and more useful programs. So let's go to the PowerPoint. Well, as far as the PowerPoint is concerned, there's a little bit of information here. We won't go over too much of it. AutoLISP is based on a programming language called LISP, or LISP. List processing is what it stands for. And it's one of only two programming languages from the 50s that's still in use. The other is Fortran. Lisp is used by MIT for their artificial intelligence programming, and it's used by Autocad. There are other places that use it as well, but its most common use is in Autocad as AutoLISP, at least the most common from my point of view. The Visual Lisp editor is what we're going to be using in Autocad. And then the PowerPoint has it getting started, and you go here and it tells you all of the rules here. Well, you have to write it in a text editor, but really it's be pointless to write this in Notepad or anything else, because VLisp gives you that wonderful color coding and some other tools for editing that's just really good. There are two files that will load automatically. One's called ACAD.LSP that loads in every drawing. The other one's called ACAD.LSP that loads only when you first start AutoCAD. And again, if it's found, the software has to find it to load it, so it has to be in the path. Either one of those would work. I'm going to have you call yours ACAD doc. There are times when it's useful to have a program that loads only when you first start AutoCAD. For right now, I'm going to have you writing commands you want access to all the time, so we're going to put it in the ACAD doc LSP file. I just showed you there are three ways to load AutoCAD AutoLISP programs. I've showed you one of the others a few times. I'll go back and show it again. You can type it at the command prompt. You can load a file that's already written, and you can do that by loading it from AutoLISP program, or you can use the app load function, or you can go to VLisp. What we did here was I typed it at the command line, then I went to VLisp. Let's just go take a quick look at app load. The ACAD doc LSP file is where you put all of your programs that you want to run every single time you start AutoCAD. That's not true of every program. One of the programs that I've probably showed you before, and I'll show you again right now. Let's say I've got a circular part and I want to put a circular bolt hole pattern in this. And I want that circular bolt hole pattern to have true center marks that are actually small arcs and are the right size. And I draw my circle and I go over here to layout, and I indicate that I want my scale here to be, say, 1 to 2. It's going to be too big. Should have known that. How about 1 to 4? All right. So it's going to be 1 to 4. I lock it. So now I'm all set up to put in my center marks. I don't have the bolt holes themselves in here. So one of the things I did was wrote a program that allows me to just give it a little bit of information. It'll automatically draw bolt holes and center marks that are correct, and make a layer, and that layer will be called Send, and everything will be put on that layer that needs to be on that layer. I would not necessarily want that command active all the time, so I wrote it as a separate file in VLisp. First, let's take a look at it in VLisp. So I'm just going to open it up in VLisp so you can see what it looks like, and I put it on our shared drive. If you look at our shared drive, under our drive student, there's a file folder called AutoLISP, and there are a number of programs there for you to take a look at, to use whatever you want, that are really very useful. I wrote most of them. Paul wrote a couple of them, I think, and there are some others that we might have put in there. What I'm looking for right now is the bolt center vspace command. So I'm going to open it up. Looks like this, and it has at the beginning a bunch of header material, which is what I'm going to expect you to do as well. And this is just the format I happen to use: 4 semicolons for the main header material, 3 semicolons for the section heading material. Got a little alert box, so you'll see what happens when I bring that up. That's just an explanation for how things work. And then I've got the code down here, and you can see the code is all set up, different colors, etc. Now this is a relatively involved program, not extremely, but it's a relatively involved program. It'll be a while before you get there. What I'm showing you though is how to load a program that you don't necessarily want loaded all the time. So this is its own file. It is called Bolt Center V space for viewport space is why that's called that. And I'm going to go ahead and load it, but I'm loading it using the appload function of AutoCAD. Type AP for appload. It asks you where you want to find the program you're loading. I'm going to go and find it on the H drive, under our drive student, under AutoLISP, which is right here. I'm going to find it, and it's right there. Oops, that's the wrong one. This one right here. So I'm going to go ahead and load it, close this out, and I get a little alert box. That's that thing I showed you at the top, and it tells me how it works. And it says, oh, you've got a new command called Bolt CC. Bolt CC will create a bolt hole pattern and add circular and radial center lines. The size will be metric if measurement set to 1, and it'll be based on the current setting and dim style for your center marks. It'll create a viewport. Oh, it tells you create a viewport at the scale you plan to plot, and then use this command with that viewport active. That's why I just made that viewport. The center marks will be scaled to the viewport scale you use. If you use the new AutoCAD array command to place bolt holes, you must explode them before placing center marks using this program. Well, we don't have bolt holes in here, so we don't have to worry about that. What I'm going to do now is type Bolt CC. Actually, before I do that, let's go to dim style, and let's we don't have our dim style set. You would normally do that, but on a dim styles, what I would do is set that current, delete standard. Yep. Redefine that, and let's just call that mechanical inch, since that's what we're in. And then I would make a number of changes, but the change I'm going to make right now that will affect this program is to go into symbols and arrows and say I want center marks that have a line, and I want the size of the center mark to be 0.06. That's going to mean that's the same size it's going to make the center marks in my program. So when I type Bolt CC, program says where's the center point of your circular pattern, and it's the center of that hole right there, the center point of any one hole. So I'll go, let's see something here. I'm going to go straight up to here, and then the diameter of that hole, let's make that hole 0.5. And the number of holes in the pattern, let's say there are 18. And the angle to fill is 360. It puts in the bolt holes, and it puts in the center lines, and they look like that. Fairly small, actually, because of the size of the hole. I made a fairly big circle, and so those hole sizes could be a little bit smaller, a little bit bigger. So let's go back and make them bigger. I undo, and I've got my program set up so when I undo it gets rid of the whole thing. I'll go back to the Bolt CC function. Once again, center line is here. Go straight up to here and say let's put a new one there, and let's make the new hole 1.5 in diameter, and the number of holes, well, we'll still go with 18. So now it goes through, it makes the holes themselves, and then it makes the pattern right here, and that pattern has the crosshair done correctly, and there's an arc here. Those are arcs instead of straight lines, and you got the same size as you would otherwise have. And there's one little problem, and that one little problem is that it also places an existing center line on this whole thing. So you have the radial center marks coming out here, so we probably don't need those, and this one we don't need either. So we'll get rid of that, and the reason I'm getting rid of it is because it sits right on top of the one that was created by the program. So probably what I had to do is go back and rewrite that program so it doesn't place that big center mark. But this is something that would be a little bit tricky to do if you didn't have the command, and so that's really the purpose of it. The purpose of showing it to you was to represent the idea of the appload command being used to load a particular program that does just one thing. Okay, so now we went through this, the color coding, and there's a slide here that shows you what that is. Another slide here that shows you where some of those toggles are on this. And then AutoLISP by example, that's the one we just went through. 4143 was the example I used here. Shows you could set it up in one line, you could set up in multiple lines. So now let's talk about the program structure. Before I do, I want to go back to the book. And the book chapter on Lisp starts off having you create the OO function, again with 4143. Now I'm going to scroll down a little bit. So if we take a look at how the book is set up, I'm giving you a little bit of background about AutoLISP and VLISP. I want you to read all of that material. And then it goes through and it tells you that AutoCAD commands are often actually Lisp programs. And in this case, Flatten, for instance, is an LSP. It's a Lisp program that AutoCAD ships with the software. And there are a number of other Lisp programs as well that you come shipped with the software. So it's pretty useful. As far as writing AutoLISP programs go, what I tried to do here was give you example programs that you could type up, try out, look at, analyze, and see how they worked. And let's talk about program structure in just a minute. But what I wanted to do was to show you how, as I'm going through each of these programs, most of this material is the same as what we're about to cover. When I actually give you individual programs to write, and the next one we're going to do is going to be a zoom command, what I'll do is show you the program itself. So here's a case where that's what the program looks like. And then below that, I've got a table in every case in both chapters, both Chapter 8 and Chapter 9. I'll show you a line of code and then explain what that line of code means over here. And that's step by step for every single program that's in your book. The reason for that is so that you can really analyze what you're writing and understand what each piece does so that you can then start applying that to other situations. Don't just type in exactly what I show you here, have it run and go great and walk away. The idea here is to understand what you're doing and how it works. And that's why I spent so much time going through these explanations right here. What I'm going to do now is I want to go through the other examples in the book. I'm going to start with a zoom command. And the zoom command is a good example of how a command structure works. And it's shown right here as the line itself. For the very first command here, I have put a long explanation for each element of that program. When I say long, I just mean detailed. So that when you're going down through it, you look at the first line of the program and there's a whole explanation for what that means. So I'm going to go through this special zoom command that I've created. I'm going to show you how that works. And once I've done that, you should be saying, I know how to issue a command and issue options to that command all together in one new command. That means that opens up a universe of possibilities for you to at least simplify and make more efficient some of the commands you use in the software. So let's go back to AutoCAD. And right there, we're going to go back to AutoCAD. And I'm going to also go back to the VLISP. But let me just set something up here. So I've got something, let's put a rectangle around that. I've got something like this, and I am used to doing a zoom extents. And when I do a zoom extents, I know that the edge of whatever I'm doing gets really close to that window right there. And it's quite possible to kind of miss it, where I'd like to have a little bit of space there. This used to be a much bigger issue when there were scroll bars that were a big problem, but those now have been turned off. Although you could turn them back on. I wouldn't. That'd be a bad idea. But and anyway, so my purpose here is I want to have a command that when I zoom, does a zoom extents and then zooms out a little bit, which you would do by typing something like 0.95x. So you notice what just happened. I made what's on the screen appear 95% as big as it did before. And every time I do that, if I type 9.95x again, it'll get a little smaller. If I do it again, it'll get a little smaller. If I type 1.1x, it'll get a little bigger. So it's possible to control the exact zoom at the command line. You're not likely to do that because you're probably just going to do this, where you use this wheel in the middle of your mouse, you hold the wheel down and move it around. You might type zoom and then put a window around something that looks like that. But I do zoom extents a lot, and what I really mean is zoom extents and then back up a little. But you'll notice the wheel, and you can change this, but the zoom increment for the wheel is pretty big. So it's not, you don't get much control when you're doing that, although zoom factor would allow me to change that. So right now it's set for 60. If I set that for 10, now every time I move my wheel it's a much smaller amount. The problem with that is it takes a lot longer to zoom in and out of fairly large objects. But zoom factor is worth knowing. Again, set for 60, maybe even setting it down to 30 would make it a little bit more precise so it doesn't make as big a jump as you go back and forth. So what I want is this. I want a command where if I type ZZ at the command prompt, or ZX at the command prompt, maybe the name of the command in the book, I want it to do a zoom extends zoom 0.95x. So every time I do it does that with just one pass. That's my goal. So I'm going to go back to VLISP. And in VLISP, I'm going to go through the command structure with you very carefully. And there it is. So now I'm going to just get rid of this program. I don't need this anymore. I just loaded it to show it to you. So I'm back here where I have my ACAD doc LSP file. And I'm going, yeah, that was a nice command. I also want this new command called ZoomX. I'm going to use the same syntax. I'm always going to start by putting a semicolon and indicating what this is going to be. So zoom extents zoom 95%. That's just a description. It has no function as far as the program itself goes. Everything you know starts with an open parenthesis, so no matter what, you can always start this program. No matter how complicated it is, the very first thing is an open parenthesis. The next very first thing is, almost always, defun. Define a new function. If it's going to be an AutoCAD command as opposed to an internal list function, you have to type C:. Then you have to give it a name. Then you have to indicate that there is either nothing or something in the parentheses that immediately follow. Enter. What do you want it to do? Well, now here's a new Lisp function. It's command. And you'll notice the minute I type D, it becomes blue. That means it's a list function. Command in this case always refers to a native AutoCAD command. In other words, that is not a command. The letter L is an alias. It won't work in Lisp. You have to know that the command is line, right? In this case, we can't type Z. We have to type zoom. We say, let's do a zoom. Now, what's the option we want from zoom? Extends. Then we want to go back in the zoom command. We want to do a 0.95x zoom. Now we're done with that element. When I type in the last parenthesis, it's going to flash to the beginning of this line because that's the opening parenthesis for this closing parenthesis. Command is in blue because it's a function. The command names themselves are magenta because they're strings. Strings are just anything you can type at the keyboard. In quotes is a string. E is an option for the zoom command. So obviously you're thinking, well, I could issue other options as well. And then down here we have the response to doing a zoom a second time with a 9.95x. You have to put in the final parenthesis. If you don't, and you say, gee, is this thing okay? And you come over here and you check it, it's going to come up and say unbalanced opening bracket found. Do you want to add a closing one? Most of the time you're safe enough saying yes. I do that. Pick OK, and bang, it put another closing one down here. It lined it right up with this. Now, I don't normally like that space in there, so I would take it out. Now, I'm going to double click on this. It's already been formatted for me, but I'll format it again just to see if anything changes. Double click again. I'll come over here and I'll check it. This time when I check it, check's done, everything's fine. It looks like my program has disappeared, which it hasn't. What's happened instead is this window has become full size. You've got to minimize it, then go back, and then you've got your program. This is the most annoying thing about this VLISP program. Why it does that, I don't know, but it does it every time. And then you have to go back and rearrange this if you want it to be bigger. I'd just like it to stay put the way it is. So if I check something, it doesn't get bigger, but that's just not the way it works. Highlight this again, and now we're going to load it. It tells me C:(ZX, so I've got pretty good indication that I haven't made any big error here. And I come over here, come out here, ZX, ZX, press enter, and it does a zoom, extends, and makes things a little smaller. And you can see it doesn't go all the way to the edge here. Same thing here, all the way out there. So now I have a command that I like better than the traditional zoom command. Okay, so pause this video while we're making it, and then try these things out. Make sure when you do it, you understand it. And if you can do that, then there's no reason in the world why you can't do all kinds of other things as well. If you look at the zoom command, it's got a few other options as well. Besides extents, you've got center, for instance. So if you want the zoom center function, what would you do? You'd type a C for center, then you'd pick a center point. So like say right here. And then a magnification. If you press enter, you get the current magnification. So if you want to recenter something or center something and have it twice as big, you could write a command that'll do that. Zoom previous is also something that's kind of nice to have. There is no zoom previous, but if you do that, it just goes to your last zoom, last zoom. You can walk right through with zoom previous all your last zooms. That might be something worth doing. Maybe a ZP command, since you don't have one. You could write that now. Now when I say that, it's because I want to make sure you recognize that once you get some of this stuff down, it can be applied to any other AutoCAD command. So let's just say we want to do another one of those. We go back to AutoCAD, come here. So now we say, well, we've done that one, I'm going to do another one. Well, if I've got one that works and I want to do something similar, I'm going to go ahead and copy it, put it in the clipboard, come down here, paste it, change the things that I need to change, in this case zoom previous, and here I don't really want to do anything other than a zoom previous on this, so I'll just do that, and there's my whole command. It's just a command with one option. I could have done a command with more than one. Not a bad idea to go ahead and format it, not a bad idea to check it, and not a bad idea once you're done doing that to load just that part and not the whole program. Looks like we've got something going here. CP, ZP, it just is walking us back through all our various zooms. So if you've been zooming in and zooming out and zooming and doing a few other things, that ZP is going to go through and do all that kind of stuff for you. Except that I got going far enough so that it stopped zoom previousing and started undoing. Now that is really interesting. I'm going to try something here. Huh. Well, I just discovered something interesting. Zoom previous does not just zoom previous. Let me try something else here. Alright, I've got a circle drawn. This is something I've never noticed before, and I'm just checking to see if it really is doing what I think it's doing. So I'm going to do a zoom. Let's do a zoom X, okay? Let's now do another zoom and go here. Let's do another zoom and go there. Let's do another zoom all. So now I'm going to use my ZP command, which is just a zoom previous command. And I'm going to back up and back up and back up and back up. I'm going to repeat this, repeat it, repeat it. All I'm doing is zooming previous. We get there and it says, do you want to undo everything? And it turns into the undo command. That's a problem I've never noticed before. That's a Lisp problem, though, from my point of view. I mean, a AutoCAD problem from my point of view, because there's no reason for that to do an undo when what I told it to do was a zoom previous. Good thing I do these videos once in a while. That was a new one on me. Point is that you can apply what you've learned about one program to another. Now let's do something with a command. There's a example in the book where I'm using the diameter instead of the radius when I draw a circle. So if you go to circle and you pick a center, and once you pick the center, it asks you for the radius, not for the diameter. So if we could just have you go ahead and put in a diameter, D for diameter, then you could type in a 4 for diameter, that would be kind of nice. And there's a way to do that in AutoLISP, and that's to have you pause as you're going through and then give you a chance to type in the letter D instead of the letter R. It's always bugged me that radiuses are used for circles in AutoCAD and not diameters, but it's just the way it is. So we'll go back here where I'm going to write another command. I'm going to go look at the book to show you where this is, and then I'm going to improve on that. We have here. Yeah, so then I'm going to improve on that, and let's go to the book. So now the ZX function we talked about here. We've seen a lot about that. Now here's one where we have circle dia LSP, where I'm going to define the letter C not as the circle command, which is what it is right now, but as the circle command that I am modifying. So if I go to AutoCAD right now, wait for that window to go away. If I go to AutoCAD right now, if I type the letter C, it's circle. But that's an alias, that's not the command itself. So what I want to do is to say, what would it take for me to change that so it's asking for a diameter instead of a radius? Well, if I go to the circle command, it's going to ask me for the center point. So I need to stop and let the user pick a center point. Then it asks me, what do I want to do? I can type in a D at that point. Then I can type in the value that I want. So if I go back to VLISP, I say, all right, we're going to do a new circle command with a diameter. So now I'm going to say, let's define a new function, just like we did the others. The function is going to behave as a command. It's going to be just the letter C. Open, close, because you need them. Open, command, circle, oops, pause, D, and then end. So all this is going to do is going to issue the circle command, let you pick a center point, issue the D, and then wait for you to give the diameter of that. So we're going to go here. In fact, we could even put a little note here. You could say, select the center and give the diameter of the circle, colon, space, quote. If you have an open quote, you need a close quote. And I'm going to put a colon and a space because that's how AutoCAD always does its prompt. So now we've got a little bit of information here in another AutoCAD or AutoLISP function. I'm going to check it. Checking's done. Looks pretty good. Come back over here, load it. Come back over here, type C. Select the center and give the diameter of the circle. Here's the center. And now the diameter of the circle is 10. So instead of having a circle command that asks for a radius, I have a circle command that asks for a diameter. Very simple little change, and because I want these to be simple at first, I want you to understand what you're doing with them, and then you can move on from there. So now let's go back to the PowerPoint and the textbook too in a minute. All right, back to PowerPoint, a couple things to clarify. The word variables. There are really three kinds of variables that you'll be dealing with when you're doing Lisp code. First kind are what's called system variables. This PowerPoint's obviously a little out of date. There were 584 of them in AutoCAD 2008. I'm thinking there's close to 1,000 now in 2021. I haven't counted them, don't feel like counting them, but I could count them. And one way I could count them, well, let's go back and count them. I'm going to go back to AutoCAD. I'm going to set a variable to the default setting because I have changed it, and I change it all the time so that I can, well, I'll show you in a minute. One of the problems with getting information from AutoCAD is if you look at the text screen, I just got that by pressing the F2 button. You might want to go and see everything that's in this window, but by default it only has 200 lines. I'm going to set it, I'll show you the problem. I'm going to set what's called an environmental variable. This is a distinction between it and system variables, but I'm doing this to show you something about system variables. And there's an environmental variable called CMD HIST lines, stands for command history lines, and it's set to 200 by default. So I'm setting it to 200 because I'm going to show you how you could get a list of all the system variables in AutoCAD if you wanted to and figure out how many of them there are. if I go to Setvar, that's not correct. If I go to Setvar and press enter, Setvar is the command that allows you to set variables. If I press enter, it wants the name of the variable I wanted to set. If I type the question mark, which is the only option right now, and press enter, it asks me which variables I want to list. If I say all of them, it'll go through, and one line at a time, it'll show me all the variables. And if I wanted to, I could copy them one line at a time. And eventually it will stop. Okay, now it did. Stopped here. The problem is, if I try to go back now and take a look and see what all those variables are, because they all got listed, it's only going to show me 200 lines, and there are far more than 200 variables. So there is a variable that I always change, but it's not an AutoCAD variable. Now here's the distinction that's important. We list that right here. We'll go back and look at the PowerPoint too, but a system variable is saved in the drawing file or registry. An environmental variable is an operating system variable, and it's different than a system variable. Also misspelled environmental. By the way, don't forget that there is a spell check command in AutoCAD, and if you do that, it'll go find misspellings for you. It'll even give you a choice that you can then pick and say change. When you change it, now I'm all done. It's probably the most underutilized command in AutoCAD. So I had an error. So those are two kinds of variables that we're going to be talking about. Now the environmental variables have a really special format. You can't just type the variable like osmode is a system variable. You can't just type it and then put in a number. You've got to use AutoLISP to change the variable. But it's not an AutoCAD variable, and it's not an AutoLISP variable. It's a environmental variable. In order to change that, I'm going to set env. That's a list function, means set environmental variable. I have to put quotes around it, and here's one of the few things that you'll have to worry about case in the programming that we're doing. We're going to have an uppercase C, lowercase md, uppercase h, lowercase ist, uppercase L, lowercase lines, quote. That's the name of the environmental variable. Then the largest value it can have is 2048, I think. I'm going to type that in. But even though it's a value, it has to be typed in as a string. Let's see if that's true. Yeah, 2048. Can't have any more lines than that. Now it allows me to see all kinds of lines. So now if I say, let's take a look at the Setvar function. Let's go to the question mark, which is right here. Let's go to list all of them. And every time it asks for press enter to continue, I'm just going to keep pressing enter. And I'll do that and go down through all the variable names until I get to the end, which is right there. So that's as far as I'm going to go. Now I'm going to right click. I'm going to copy the history. I've got 2,000 lines now, so let's just see how many lines we actually created. I'll type Notepad and go into the Notepad text editor. I'll paste all these lines. I'll go to the end, and there's 1,200 lines. So this is one way to get a listing of every single variable in AutoCAD. Now if you really wanted to do something with that list, like turn it into a script that would reset your variables to the way you want to reset them, you'd have to do a few things. One thing you'd have to do is get rid of anything that said read only, and there's a whole bunch of things that do. Let's just kind of go through an editing process here as well. This is related tangentially to AutoLISP, because you have to use AutoLISP to get to the environmental variable that you have to change in order to get this full listing, in order to copy it and put it in the Notepad. But what I've got here now would not make a very good script, because there's all kinds of extra spaces, there's stuff over here that shouldn't be there. So if I go to the top of this list, And the top of that list, actually, we can get rid of some of it because we ran it twice. And you'll notice that the first time we ran it, this is all that we could get for lines because it only went back to 200 lines. But I don't need that because it's been repeated down below. I'm going to go down to where we first issued the Setvar command, highlight all of that, go to the beginning. When I get to the beginning, I'm just going to delete all these lines. Now I could start a script like this that has a listing of all the variable names, but there are some things I just have to get rid of. Things like these two variables right there, they're read-only variables, so I can't use them anyway. Do the same thing down here, and to pick that I would just grab a little point here and the left click, go down, enter, and it gets rid of it. So you'd have to go down through and get rid of all that. The other thing you'd have to do is get rid of press enter to continue. Well, there's a number of those. So if I highlighted them, copied them, went to edit, replace, then press enter to continue shows up, go back and pick nothing, replace all, now all those things disappear, but we do have to get rid of the spaces. And again, anything that has read only, you just have to get rid of it if you're going to use this to make a script for resetting all your variable names. There are other ways you can do this as well, including that default file, but this one you know for sure these are your current settings, just because I think it's useful sometimes. The other thing is we need to get rid of every single place that has more than one space. So the other thing I would do is go up here, go to replace, say replace a double space with a single space, and go down through and say replace all, replace all, replace all, and you can see what's happening. All of those places with a double space are gradually moving over. So this now could be used to set those variables. So the point of this is that you've got, just going to throw that away, three kinds of variables, and we've looked at system variables like osmode. We looked at one environmental variable, command history list, and there are some others as well. That's the one you're most likely to want to change. And the other kind of variables are actually AutoCAD, AutoLISP. In fact, we'll just call them AutoLISP because even though AutoLISP is part of AutoCAD, they're only variables in AutoLISP. So AutoLISP variables that are created by the programmer, which is you. In other words, you can create your own variables. To do that, use a function called setQ. And I think of that as standing for set equal to, even though it actually means set quote. But that's the function you use to create a variable. So what I want to do is to go now and take a look at another type of program where you're actually going to create variables so that you can use that variable throughout the program, but it actually can vary. So we're going to look at the PowerPoint again. Getting better, setQ. We're going to go take a look at a program. Also going to look at the textbook where that program is laid out and discussed. That is right here. So if we get on past the circle program. Now this is what the program looks like. Up here it shows it to you listed in the same way. And over here it's in color in the textbook. Your textbook's black and white. I selected that, by the way. I was given the choice of glossy paper with color, and then the book would cost you $80, or black and white, and then it would cost you $40. I went with black and white so that I could save you $40. At any rate, this program is used to set or insert a block, an existing block, into a current drawing. We just write a program, and when you write the program, you type it in, and it brings in a block. In this case, it's a title block. Now, I'm going to do this and show you how you go ahead and do this, and then I'm going to keep adding to it, adding some other features to it. I'm going to add. Do I need to add error trapping? Yep, I'm going to add error trapping to it, put some notes in it, and go through and just show you how I would build an actual usable program. If you look at this, the first thing we need is a drawing that we can insert. In other words, a drawing of a title block in model space. If you look at the text, let's look at over here where it's color-coded. The name of this function that I'm about to create is an AutoCAD command called ITB. In other words, I'll type ITB at the command line, and this will run. It goes and issues the AutoCAD command, insert. There's a dot and a period. The dot means that even if someone undefined the command insert, which is possible to do, in fact, it's you know, once in a while I'll do that as a joke on April 1st in the lab. I'll undefine the line command and then redefine it as something else, just to see what people do. And then I change it right back, of course. The underlining means that even if you've got a foreign language version of AutoCAD, it'll still understand that the word insert means run the insert command, because AutoCAD's native language is, in fact, English. So those aren't necessary, but I put them into the book because the book was being distributed worldwide, and in fact it was translated into 4 languages, so those people will use those languages, may or may not use the English language version. But the languages it was translated into were Russian and Bulgarian and Romanian and Croatian, I think. At any rate, as a result, I wanted to make sure that if somebody were to write this and run it in a program other than the English language version of AutoCAD, it would run. It's going to go and find something. In this case, C: actually does mean the C drive. Up here, it means AutoCAD command. Down here, it means the C drive on your computer. This is a little thing that really, really bugged me for a while when I was first learning to write Lisp programs. I kept trying to insert drawings into other drawings, and I couldn't do it because I would put a backslash here. Backslash is actually, it's got a function in AutoLISP. It's already been defined, so you can't use it in a case like this. You've got to use a front slash or a double backslash. The first of the double backslashes is a control character saying read the following character literally as a backslash. So that's really the only thing you need to know about this. So what happens when you do insert at the command line? You have to give the location and the name of a drawing file. Then you have to indicate where you want to put it. And then you have to answer those questions about, I forget the order, but I think it's scale, rotate, and, well, why am I trying to remember? I don't have to remember everything about AutoCAD. Neither do you. I can just go to AutoCAD and find out. So we'll go to AutoCAD and I'll just make sure that I know how to make this work. So I'm going to do negative insert so I can have the command line version of insert. Because otherwise, if I typed insert, it's going to give me an unhandled error exception again. This keeps coming up. I talked about this in the Puzzlers. It's because the 2021 added a different kind of visual Lisp interpreter, and it broke this on my computer, and I think on some others as well. I know on some others because I've seen it online. So I don't want that to happen for sure. Before 2021, when there was no palette for the insert command, it would bring up this dialog box if you would have typed the letter I or the word insert. So negative insert brings it up at the command line. So I can go in and say, let's insert a drawing. Now I'm not in a Lisp program now, so I can say C: backslash blocks backslash tb_inch.dwg. The problem is, when I press enter, it's not going to be able to find it. Because, and by the way, this is a good quick way to find out what the search pattern is. Search path is, I mean, in AutoCAD. If you try to insert a block that doesn't exist, it'll tell you where it looked for it. And it couldn't find it, and it looked in the entire search path. So one problem with this, and you've got to be careful, I've had people in the past who would really literally go through and copy things like that from the book and then say it didn't work. Well, it won't work if you do not have a folder called blocks that contains a drawing file called tb_inch.dwg on your C drive. There won't be anything there. So what I'm going to do right now is pause this. I'm going to go put a file in that location. Then I'm going to come back. So I'm back. Now if you notice, I have a C drive. I have a folder called blocked, and in that folder is now a drawing called tb_inch. I'm going to go back to AutoCAD now. And again, from the command prompt, I'll go moving back up. I'll do the insert command, and when it asks me for the name of the block, C:, the C drive in this case, backslash, blocks, the name of the folder. Hit enter a little too quickly here. C:, backslash, blocks, backslash, tb_inch.dwg, enter. Now it finds it, so it doesn't give me that error message and asks me where do you want to put it. So I'm just going to say, well, put it at 0, 0, enter. What's my X scale factor? 1. My Y scale factor? Use the X scale factor. So now I'm just pressing enter, enter, and then rotation angle, enter. it pops up. In this case, it pops up and asks me some questions because there's a couple of attributes associated with it. I pick OK, and now it inserts it. If I go to look for it, it's right down here at 0, 0, and it just inserted that block. Now the point of doing this, of course, would be to have a layout, and in the layout to go in and say I want to do a setup. So I go to Page Setup Manager, and I'll modify the existing layout. I'll go over here and use DWG to PDF. We'll do an ANSI expanded B. So expanded A right there, expanded B. That's what I'm going to set. I'll set my plot style to monochrome. And I've got a set of B-size paper. Now what I'd like to be able to do is to go and insert the title block. And I need to go and find it, C:// blocks / TB title block inch.dwg, enter. Now I'd like to just keep pressing enter after I go to 0, 0, enter, enter, enter. One more enter, comes up like this. I say OK, and it comes in and it's sitting exactly where I want it to sit. In this particular case, it doesn't quite work. Oh, what the heck, let's go and edit that. So I'm going to go back and open that drawing file. I'm going to edit it so this goes down a 1/4 inch so that I have room at the top for those letters. I just grabbed an existing title block and it just doesn't quite fit on this sheet of paper. So I'm just going to open, oh, you don't need to see this, I can make this. So in order to test this, I'm going to get rid of that title block. Now I've already inserted it once, so it's already in this drawing as a block definition. So if I do block edit, you can see TB inches in there. But now that I've erased it, I can purge that block. And so I can go and say purge the block. Well, I can't if I don't erase the one that's over here as well. I'm going to do that. Now I'm going to purge. I'm going to purge. And the only block I can purge in here is the one called TB inch. So I'm going to pick that. Go ahead and purge everything I've selected. Purge this item. Purge this item. Oh, I picked purge all, didn't I? I meant to say purge checked items, so we'll do that. Anyway, so I've gotten rid of now the block representing TB inch. Now I go back over here. So what I'm after here is for this to work. And this is how I want you to test these out, or to plan these out before you start typing in Visual Lisp, is to make sure you understand how the command works. So I'm going to say let's insert C:/ blocks. I keep hitting the enter key. My mistake, sorry. /blocks /TB inch.dwg, enter. It comes in. Now if I do 0, 0, enter, 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 that comes up. I pick enter again, hit OK. Now you notice it's coming in exactly where I want it to go. So now if I were to do a preview, I've got a title block that fits right where I want it to go. So the point is this: I don't feel like going through the negative insert and then going through and typing all of those things. So I'm going to go to VLisp, and in VLisp I've got that ACAD doc file I've been working on. And I'm going to come down here and I'm going to put in some code. So I'll say automatically insert a block from my block folder. Now there are other ways to bring blocks in, including putting them on the tool palette, and that's probably a really good way to do it as well. But I'd like to have a command called ITP that just does it automatically. So we're going to do what we've done with every other Lisp program. Start with an open parenthesis that's red. Define a new function, defun, blue. Act as an AutoCAD command, C:/ITB. That's my name of my command, insert title block, open close parenthesis, enter. Now I indicate what I want it to do in one or more lines. And what I want it to do is to go and issue the command insert. Now I don't have to put a negative in front of it in AutoLISP because it won't open the dialog box. I can just type AutoLISP. I type insert. I'm just curious though what I did in the book. I don't remember. Yeah, in the book I don't put the negative in there. I just put the period and the underscore. Again, if you're going to have your program used by people in other countries, or it's possible that somebody might have undefined the insert command, then you'd want to do that, but it's not really necessary for the purposes of this assignment. Now you'll notice something in the book. In all of my examples, I use uppercase letters for the names of AutoCAD commands, just because it's easier for me to kind of find them as I look down through it. And then I use lowercase letters for everything else. So I'm going to use uppercase for the insert command here. So now I've done the insert command. What do I want to insert? C:, double backslash would be fine, or a single front slash would be fine. tbinch.dwg, enter, 0, 0. In other words, that's where I want it to go. 2 quotation marks side by side is the equivalent of pressing the enter key. And I need to do that 3 times to get out of this. Now it's going to leave me with the attribute request box open. It's going to ask me what the attribute values are going to be. I'm going to use that as a problem to solve here in a minute. I close the program out like this, double click, highlight everything, test it, everything looks pretty good, go back out. I'm going to actually then format it, make a small change when it brought the last parenthesis over. Now I load it. It tells me I have a new command called ITP. I'm going to erase this. I'm going to purge this out so that you can see that I'm not bringing it into a drawing that already has it in. So I want to get rid of that. So I'll purge checked items, come back out. So now ITB, press enter, bang, it opens this up. Opens it up and asks me for the title. So I'll put in Arbor. No, I'll just put in Arbor. Then go down here and pick OK. And now it's just going to drop the title block in place, and it's going to have that title filled in. Now let's just say I really don't like having it ask me that question. If I type ITB, I just wanted to come in and I'll put in the title later on. Alright, let's back up. Now I just backed up before I inserted that, which means I don't have to purge anything. Oh, I just undid the purge. I do have to purge something because I went back one step too far. Now I'm going to purge checked items again. So now there is a variable called @request, and it is turned on right now. If it were turned off, it wouldn't be asking me questions. On the other hand, I have it on because normally I want it on. Let's say I don't want it on for the purpose of this assignment, of this particular program. So I'll go back to Visual Lisp, and now I'm going to start improving this command. Now it's something called Visual Lisp or Lisp command bloat that happens sometimes when people decide to throw the whole kitchen sink in, and that's kind of what I'm doing here. But I want to show you how you can gradually build on something to make it better. What I want to do here is I want to set, I don't want that uppercase, I want to set the variable @request equal to 0. That way when I bring this in, it's not asking me that question, it just inserts a block. However, I don't want to change something in my program that's different from what the current settings are without changing them back. This is called polite programming. So what I want to do first, before I set @request equal to 0, I want to set it equal to 0 only after finding out what it is currently set for. It may already be 0. It may be set to 1. Those are the two values. So this is my explanation for what I'm about to do. If you offered to house sit for me, and I said, yeah, I'm going to be gone for 2 weeks. And you said, great. And I give you the keys, you come over, I show you where everything is, you meet the cat. And then I leave and you're going, he's going to be gone 2 weeks. I do not like the arrangement of the furniture in this living room. I just would really prefer to have that couch over there. If you take a photograph of exactly what it looks like and then move the couch, later on, 2 weeks later, when you realize I'm coming home in 30 minutes, you get that photograph out, you can put everything back the way it was. What I'm about to do in Lisp terms is take a photograph. I'm about to getVar, get the value of a current variable, @request is the name of the variable I want to get. Now, by itself, that will actually tell me what the current setting is. If I do this and then load it, down here it tells me it's 1. It says that right here. That doesn't allow me, though, to remember it. What allows me to remember it is the photograph. So you're not just kind of walking in and going, yeah, I can see where everything is, and then later on go, I used to know where that couch was, and now I don't exactly remember where it was. So what I want to do here is to set a variable, set equal to, and I'll call that variable AQ for at request. Or let's make it a little clearer, ATTREQUEST. And in fact, since I'm really doing something that's 2 words, I'm going to use what's called camel case here so that I can tell it's a variable name. So I'm going to just say, I'm going to find out what the current setting for at request is, but I'm going to save it to a variable named at request. So now if I do that, not only does it return 1, but that variable right there, if I right click, do something called add a watch, it'll tell me that at request as a variable name is set equal to 1. Now it took me a while to get here, but that's the third kind of variable that we're talking about, a variable that you define when you write a Lisp program so that you can use that variable in other places. It would be impossible to do anything like serious programming without the opportunity to create your own variables. And by the way, a variable can have a value equal to it as a number, it can have a string, anything you can type. It can have an object. It can have a set of objects. It can have anything at all that is possible to identify, either singly or in a group, in AutoCAD. So what's the good of that? Well, once I'm all done, see, once I've set that to 0, it's just going to come in and then be done. Once the program's all done, I can go down and say, now Setvar, not setQ, we've already got the variable defined, Setvar at request equal to, not 1, because we don't know that it was 1, but this variable name. I'm just going to double click and copy it and bring it down here so I don't mistype it, because it has to be typed exactly the same way. So now what's going to happen here? First, when I run the program, it's going to query AutoCAD and get a value, the variable value for at request, save it to a variable name. Again, I'm using the word variable in 2 different ways here, system variable, Lisp variable. Then it's going to set that variable equal to 0. Then it's going to insert my title block. Then it's going to set that variable back. I double click. I'll format it. Actually, in this case, I wish I hadn't because I don't like that extra space at the end. I'll then go ahead and check it. Checking's done. I'll go back one more time and I'm going to load it. Look down here. It made a new command for me. I'm going to type ITB, press enter, bang. Puts it right in there. It doesn't ask me the question, but if I do an at request right now and check it, the value was set back to 1 after it ran. Okay, now let's make this even better. Go back to the book. If we go back to the book, the beginning program details exactly how it works. Then it goes down here and says, how about using a variable? And here it's using a different kind of variable. The at request I didn't put into the book because the particular block I was using to test it, I hadn't put any attributes in. I just put that in now because I realized I had attributes and this would be a way to turn them off. But there is something else that's going on here. What I want to do is to find out where that title block should go. Now, this is probably a little more cumbersome than you would normally do. You probably have a layer for your title block, and it's probably already got a name, and it probably already has a color. But I'm just using this to demonstrate how you can get data from the user and then use that data. Let me see if it's on the PowerPoint. Oh, actually the at request is on the PowerPoint over here. So that's so the book didn't use that, but the PowerPoint did. Okay, now we're down here where Okay, so that's one. Okay, I'm just looking to see if I included the @request. I'm going to leave the @request variable change set. So I'm looking over here where it's all color coded. So what's happening over here is this I guess was a new command that I created called insert TB just to differentiate it from that one. I'm just going to improve the one I have. So I come over here and it says set Q LName. Well, LName is in black. If it's in black, it's because I came up with it. I typed it in. And that set Q means set equal to. So I'm creating a new variable with the name LName. And I'm going to put some value in that variable. It's called binding a value to the variable. In this case, I'm going to use a function called Getstring. And a string is whatever someone can type at the command line. I'm going to get a string with the letter T stands for true. And that's simply something I need to do in case somebody has layer names with spaces in them. I don't normally do that, but some people do. So if you're going to want to allow someone to put spaces in a layer name, you have to put the letter T there. Now I'm going to give them a prompt so that the user knows what it is I'm expecting of them. And the prompt is going to start on a new line. And it's going to say destination layer : space, because that's the syntax that AutoCAD uses. And then it's going to close. What that's going to do is allow the user to type something and press enter. Whatever they type will be saved with the layer name, with the value assigned to LName. So if I typed border here, the word border would be bound to LName, and then I could use LName down here after the insert command to change. In fact, I'm going to do a little differently so that you see another approach to this, but I can use that to create a layer with that name and to change it to that layer. Yeah, let's do that. Oh no, I see why I did this. No, I'm going to do it the way it shows right here. I forgot that I wanted to have you see the end last. That's why I did it this way. Alright, so there's only one line here that's common to what we had before, and that's this line right here that actually does the insertion. So I'm going to go back to VLisp, which is right here. And now I'm going to say, alright, we took care of that one. That's awesome. Now what I want to do is to set Q LName, that's the variable that I created, equal to Getstring. You notice as soon as I get done typing it, it turns blue. Getstring, T for true, quote, \n. That just means it drops down to the next line. This has to be a lowercase n. There aren't many places where case matters, but this is one of them. Now, it just means that it's not going to show up in the same line, in the same part of the command line as everything else. So instead of having things strung out, it's a way to have a carriage return so it comes down below. So, give name of destination layer. Now you can put anything you want in here. This is just a prompt. You could say, hey, nice haircut. Give the name of the destination layer. It doesn't matter what you put here. It's just going to be prompting you at the command line to do that. So if I say that, enter, enter. Now I'm going to test this one line of code, which again is what I want you to do as you're writing some things that are a little more involved. Don't wait to test the whole thing when you're done. Write a line of code, come up here and test it and see what happens. Goes to AutoCAD, says give me the name of the destination layer. I can say, oh, I want the destination layer to be called border. Enter. Alright, now what happened? Over here I've got a watch window that has values in it. I can add any variable I created here to that watch window. All I have to do is right click on the variable name, add watch, OK, it comes in over here and you'll notice that variable name right now is set to border. That means the value border is going to show up anytime I use LName. Well, I'm going to go back and do something else in a minute too, but before I get done, I'm going to separate this now. So up here I'm getting information. Then what I'm doing is using the information down here. So just back up. Okay, so what I'm going to do here is this. I'm going to create a new layer. And I'm going to create the new layer by saying command layer make. Now it's going to ask me the name of the layer I'm trying to make. And so I'm going to indicate that the layer I'm trying to make is LName. And we'll just try that out just the way it is. So I come back over here, double click. Oh, I put an extra parenthesis in there. And now I'm going to go back here. I'm going to double click that. I'm going to do this. Now let's go back over here and see. I'm still in the layer command here because I didn't have 2 enters to get out of it. But if I look at the layers right now, I now have a layer called border. And that layer called border was just created by that program. The color of the layer called border is black. So we'll go back to VLISP right here. And now I'm coming up here and I'm going to say, you know, I also would like to have a color assigned to it. So set Q, L color, layer color. Once again, I'm going to do a Getstring. And here's where I sometimes just say, listen, I know that one works, so let's just highlight it, copy it, bring it down here and paste it. And then we can just change, give the color of, and if I wanted to really be clever, I could say give the color of, I could put a quote here, and then I could insert L name here, have another quote here, but what I'd have to do is do a string cat function to put all these things together. This is probably a little more than I should be doing in this first one, but so anyway, so let's see if this is going to work. What I want to do is see if it asks me what the color is that I want. So give the color of, and what I'm doing is I'm putting what I put up here in here. Let's just see if that works. Double click, load it, give color of border destination layer. Oh, you know, here's why. I look at this and I go, wait a minute, I wanted a space here and I don't want the word destination. I just want to get rid of that, and apparently I didn't do that. So let's go back over here. Give layer of, I need a space here, and I don't want the word destination here. I want just the word layer with a space in front of it. Now let's see if that looks any better. Come back up here. Give color of border layer. So let's say I want the border layer to be yellow. So now I come back here, right click on layer color, add it to my watch, and now I know that the value L color is yellow, L name is border. Why are they called variables? Because every time I run it, I get to put in a new name. Now I could also add a default. That goes a little beyond what I'm doing now. I'm going to come back to this later. Not in this video, but in another video, and do a default. So now I've got some things here. I've got my layer down here that's been named L name. I also want to then add a color. So I'm going to say, let's go in, because we're still in the layer command, don't forget. Once you name a layer, you're still in the layer command. So C for color. It'll say, what color do you want to set? And I'll say yellow. No, I won't. I'll say L color. That was the whole point. I'll say L color. It'll say, what layer do you want to assign it to? I'll say L name. So now, command layer, make a layer called whatever is bound, whatever value is set for L name that came up here. Change the color to whatever color was given up here. Assign it to L name. And then let's get out of the layer command. Let's see what happens now. Come back over here. I'm not in the layer command anymore. I come down here. Border is now yellow. And that's all because of that program that I'm writing. Now that's not, well, it's enough for right now. So let's try this out. So I'm going to double click the whole thing. Let's format it first so it looks nice. And so I did a nice job there formatting things. It's going to put closing parentheses under the opening parentheses. So I like this formatting function. We'll double click on it again. I'm going to check it to make sure everything works right. So far so good. I'm going to load it to make sure it loads okay. It loads, gives me ITB. So I'm going to erase that. Once again, I'm going to purge the block. I'm going to purge the block. So I say need both of them. I'm going to purge the block so it's clear that I don't have anything in here. Now again, at request is currently set to 1, which would normally mean bring up the at request dialog box. I type ITB, give the name of the destination layer. I'm going to give it a different name this time. I'm going to call it title block. Give the color of the title block layer, make it red. Enter, it comes in. The reason, by the way, it didn't turn red is because all the elements in this title block are already on other layers. But if I go here now, I have a title block layer that's red all by just running that command. Now, the way to deal with this video is for you to sort of go through this, stop, try it out, try to make one of your own, set up a folder that has a title block in it. And when you can make it work, make sure you understand all the things that you did. And if you do, you now have a handle on a number of different functions in AutoLISP. We go all the way back to the top. You, at this point, really understand you define a new command. Whether it's a command or anything else, you're going to use defun to define a new function. You have to have everything enclosed in parentheses. In order to make a function that acts like an AutoCAD command, it has to have a C:. You can set variable values if you want. You can create commands that have options from selected, so you can go to a standard command and just issue the options. You have a pause function that allows the user to have some input, or you can have even more input. This one down here, that one's with blip mode. I guess I must have gone over that earlier. I don't remember if I did or not. Anyway, this is a sort of boosting the circle command, or a somewhat different approach, so you don't have to use a pause. And then we did this one. So now you not only have setvar, we did do setQ here. SetQ, set equal to, we'll look at it down here instead. So you know this defun function, the setQ function for creating variables. You create variables so that you can use the value, and the value can change every time you use it. You are getting the existing value for a system variable and setting it to your own variable so that you know at the end you can return this. You can have some good housekeeping going on. Then we're going to set a variable equal to something just for the purpose of this particular program. Ask the operator for some information, ask the operator for some other information, insert the block, then I go over here at command layer. Oh, but did I? Oh, I made the block though after inserting this, so we have to do one other thing here. The other thing that I have to do is change the properties of the block I just inserted to put it on that layer. This would have worked out just fine if I'd done this in a little different order. In fact, we'll fix this in two ways. Let's take that line right there and cut it, and then come up here, down here. So now I'm making the layer before doing this, so it's coming in on the current layer, and the current layer is whatever layer just got named. But I don't want to end this by being on the title block layer. So down here I return setvar at request back to the setting it had at the beginning. I'm also now going to do something called set the layer to the previous layer. Now how do I do that? Let's go up here and see something. Is there an option under layer for setting it to the previous layer? You look down here, doesn't look it at all. But there is a command called layer P, and layer P stands for layer previous. So if you notice, my current layer is a title block layer. I press enter, it goes back to the previous layer. I'm going to undo that, and I'm going to go, no, actually I do want to do it. Let's go layer P, go back here, go back here, go back here. So now I'm at layer 0. So I've undone all my layer changes. Nothing else has changed, just my layer change. We'll delete the title block. We'll go in and we'll purge all those items right there. Now let's go back to VLisp. And now let's issue the command layer P, which I should have uppercase. It doesn't have to be uppercase, that's just my own little thing for AutoCAD commands. So everything else is lowercase, that's uppercase. So I'm going to just say Command Layer P. That should take me back to the previous layer. So now I'm going to load this once again, go back and look. We're on layer 0 at the moment. ITB, give the name of the destination layer, and we'll say title block again. Give the color, let's give this one the color blue. It comes in, it inserts it. I'm on layer 0 still, but if I pick the title block is on the title block layer. Title block layer is not blue though, so something didn't work. Let's find out why. Oh, it is blue. Why didn't I think it was blue? Because it is not showing blue there. Title block. No, it isn't. Alright, well I have to go back now and do some troubleshooting. If I go back to do some troubleshooting, this is great. This is exactly what happens. Let's just find out what's going on here. L color is blue, and the reason is because layer per, that doesn't look right. Let me see something here. If I look at layer color is set to blue. So if I say let's come up here and run that line right there, let's see what happens. Run that line right here, come back out. Title block layer is blue. Layer P goes back to 0. And the title block layer, so it goes back to the previous state. Wow, that's not going to work for me then, not the way I thought, because I didn't expect it, but it turns out that when I do layer per, it also changes the color of the layer. I don't want that to happen. Now, I'm not sure exactly why that happened, but now what I'm going to do is say, okay, I've got to do it. I have to take a different approach here. The different approach here is going to be this. I'm going to go ahead and take the insert function and I'll put it back where I had it to begin with, up here. So it does the inserting, then it goes through and it's going to create the layer name. We'll put that up here just because it's a little easy to keep track of. Now it makes that new layer and it gives it that color. And I'm actually going to make that an N instead of an M. That way the new layer is not the current layer. It just makes a layer. If you make a layer using the make option of layer, it becomes the current layer. If you make a layer using the N option of layer, it's a new layer, but it doesn't make it current. That means I need to put the title block on that layer after the layer is made. I'm going to do that, and I also want to get rid of this because that messed me up. This is great. You get to see troubleshooting in real time at the same time. We got a little bit of it's getting lengthy, so let me go and do this. This might be a command you're not familiar with. I'm going to use a command called CHPROP, CHPROP, and what it allows you to do is this. CHPROP asks me to select an object. If I select that object right there and press enter, what do you want to change? I can say let's change the layer. What do you want to change it to? I can change it to anything that I want. Now I'm going to erase this. I'm going to undo. I'm going to undo back, say, 20 steps. Now let me see what I am with layers. I'm going to go back even more. Undo 20 more steps. Go back and see where I am with layers. Now I've still got T block as a layer, so I'm going to undo again. I'm going to go back 20 more. And now I am back far enough that I probably don't even have a page set up, so I'm going to redo. I'm going to undo again, but I'm only going to go back 5. What I'm doing is kind of zeroing in on where I want to be by undoing back increasingly smaller numbers. I'll redo this one. Let's go undo back 3. Redo. See what we have for layers. Oh, T block came in with this block, so let me get rid of that. And let me purge that so we're back to where we started. And I am going to leave it at that. Alright, so that's what we have right now, and those are the layers that came in with the title block. Now we'll go back to VLISP. I'm going to double click at the end, and you can see that I need to change prop. Alright, so what I'm going to do with change prop is I'm going to change the last thing that I created, which is that title block that I inserted. So this is a way of picking the last thing that I created. It's very much like in AutoCAD when you ask to select something, you type L for last. This is the ent last, the last entity created. And I have to do that because it's expecting me to pick more than one thing. So I have to press enter again to say I'm done with my selection set. I want to change the layer that it's on, and I want to put on the layer called L name. And I think I also need one more enter on that one as well. Now let's do that and check it first to see if I have any errors there. Now let's go and load it. ITB again. Again, we don't have the title block in here anymore. As far as the layers go, let's go and just purge those layers. So I'm going to go back to the purge command, and I'm going to just pick all the layers, and I'm going to get rid of all those layers. Alright, so now I've got a nice clean drawing. There's only a couple layers here. Border layer and the logo layer, and that's probably because I forgot to select, I forgot to select purge nested items. So there were layers that were nested in other layers. Now that should have gotten rid of all my layers. How the purge command works. Alright, I have layer 0 only. I do have a page set up here. I'm going to type ITB again, press enter, it comes in, give name of destination layer. Now it's already done the insertion. Give name of destination layer. I'm going to say title block. Color of destination layer, let's say a red, enter. Now if I select that title block, it is on the title block layer, which is red, which was just created. I think I'm going to stop this introductory video and say that you have enough. Oh, no, there's one more thing I need to do. I'm going to do one more thing. And the one more thing I want to do is show you the math functions. And we'll just do those right at the AutoCAD command prompt. There are all kinds of ways to do math. So we'll do some math. We'll do one little program. So when you're doing AutoLISP, everything has to open parentheses, has to start that way. If I want to divide a couple numbers, so let's say I want to divide 6 by 3. You'd think that you could go 6 divided by 3 and then press enter, but it's going to say, well, we don't know what 6 is. It's not a function. In Lisp programming, at the beginning, your very first item after an opening parenthesis has to be an AutoLISP function. So the AutoLISP function here is actually the division function. So I have to say, let's divide 6 by 3. And then it tells me that that's 2. However, if I say let's divide 5 by 3, it's going to tell me that that's 1, which is kind of off. And the reason here is this. Do a little bit of notes here. There's a difference between an integer and a real number. And computers see that difference, and there are times when it's a really critical difference. An integer is a whole number. So you can have 2 children. You cannot have 2.5 children. Children have to be counted as integers. But you can have a salary of $100, but you can also have a salary of $100.29. So real numbers have decimal points and integers do not have decimal points. If I go back up to the command line and say open parentheses, let's divide 5 by 2. What I have to do is divide 5 by 3. I have to divide 5 by 3.0. And if I do that, I have a real number and it'll return a real number. In this particular case, it is only 5 decimal places, but I can set it up so it's more. Now, there's one other kind of weird anomaly with these functions. You can imagine there's a positive, positive sign function. So I can say, let's add 2 plus 2. 2 plus 2 is equal to 4. You probably knew that. Let's subtract 2 from 4. From 2, let's subtract 4. We're going to get a negative value, negative 2. And we can say, let's multiply 5 times 0.5. Now, you're expecting that to say 2.5, but when I press enter, it's actually going to tell me that I have an illegal dot. I've misplaced a dot. And the reason is this. You can put decimals in Lisp, but when you do a decimal, it has to have a 0 in front of a decimal point. Otherwise, it's seen as something else. Now, when I press enter, it's going to give me 2.5. Those are the primary math functions that you have available to you. So what I'm going to do, just to shorten this up a little, I'm going to pause. I'm going to go write a program. Then I'm going to show you what it does, and I'm going to talk about why it does that. Okay, we're going to do a little bit of math here. So I'm just going to show you a program that is also from your book. It is on page, let's look at the top of the page here, 295. And this is one to convert between inches and millimeters. So if at some point while you're working, you need to make a conversion from inches into millimeters, and then you can make the one that goes from millimeters into inches. In fact, I'm going to give that to you as an exercise down the road a little bit. So I have this program over here called I2M, inches to millimeters. And it's got some things up here in that space right after the command that we've normally left blank. We'll come back to that in a minute. But here's the program. I've actually duplicated it over here, and I put a little header material telling you what it does. So I'm going to go through and I'm going to run each line so you can see what happens. And I think it'll be clear to you as I do what's going on. Set Q we've seen. IN, it's black. That means I made it up. It's my integer, my variable name. So I'm going to set equal to IN and whatever happens afterward. What happens afterward is it's going to do another get function. We saw one get function, which was Getstring. We saw another one, which is get var for getting a system variable. And there is one called get env for get environmental variable. Like Getstring, it's possible to put a prompt into this particular get function. The difference is that getDist will only permit you to get a number. And a getDist allows you to get that number in one of two ways. And this is important in this one because one of the things that AutoCAD normally does is it allows you to select 2 points on the screen if you want to give it information about the distance between the 2 points or the angle. So we're going to use getDist because we want to have a number that we're going to convert, but we want to allow people to pick 2 points on the screen to define what that is as well. In fact, just so it's obvious, let's go back to AutoCAD, and I'm going to draw something in AutoCAD. Go back to model space. I'm going to draw a rectangle. I'm going to just draw it starting anywhere. Let's make it at 25.4. Actually, we're going inches to millimeters. I'm going to at 1, comma 1. So I've got a rectangle that's 1 inch by 1 inch right now. Now I'm going to go back to VLisp. We're going to do one at a time. We're going to run these different lines. So if I do this to begin with and then press load selection, it says what's the value in inches. I can pick 2 points like those 2 points right there. Now it knows that the value is 1. I may as well have typed 1. Alright, nothing happens. Although IN, if I were to add that to the watch, which is over here, little watch window, you'll notice IN is now equal to 1 because I picked those 2 points that are 1 unit apart. Now I come down here, set MM, and you notice what it's doing is it's multiplying, double click on that right there, it's multiplying the value of IN by 25.4. If I come up here, you can see what it returns is the value of 25.4 because there are 25.4 millimeters in an inch, so multiplying 1 times 25.4 is going to give you 25.4. But I want to save that equal to a variable. The variable in this case I came up with was mm for millimeters, which is pretty clever. Now inches says 1. Right click on millimeters, add that to the watch window so we can see what we're doing. That's now going to say 25.4. Now I'd like to report this out. I'd like to know what the response is and not just looking at the command line. So I'm going to do something called an alert box. In order to do that, I have to have something to put in the alert box. So I'm going to go and set another variable. This one is equal to quote 1.000. And it's doing that because, again, setQ just means set equal to. That's how you create any variable name. There is this function RTOS, because this is critical that you understand this when you're doing programming. Computers see a distinction between things called strings, which is whatever you can type at the keyboard that includes numbers, but they're not seen as numbers because it makes a distinction between strings and values. And the values themselves can be real numbers or they can be integers. If they're integers or if they're real numbers, they can't be put into an alert box because you can only put something in an alert box in a prompt. By the way, what is an alert box? Let me just give you an example. I'm going to create an alert box up here and just type the word alert after the opening parentheses and have an alert that says, this is my favorite, formatting hard drive. So an alert box is simply that. It just alerts you by coming up with a box and telling you something. Now obviously, if you saw that and you didn't know what was going on, you probably wouldn't pick OK, but it's not doing anything. It's just telling you something. You put anything you want there. Now, if I pick OK, it just goes away. But in order to be put into an alert box, you have to be a piece of text. So if we go back to our VLISP program, these values right here are values. 25.4 is a number. 1.0, it's a number. You can't put that into an alert box until you turn it into a string. So what happened down here? This RTOS stands for real to string. When I ran it, it took the value of IN and made it into a string by putting quotes around it. Why 3 decimal places? Because I told it to put 3 decimal places right here. What if I told it to do 15 decimal places? How many would it give me? It won't give me 15, but it will give me 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it does give me 15. I didn't think it would go that high. Maybe something changed. Let's try 20 and see what happens. This would be really cool to discover. Not that you ever need, no, it's the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it went as far as it can go. The point here is that when you do this, you can indicate how many decimal places you want here. And here you can indicate what format you want it to be in. So now I'm going to convert that real number into a string. And now it's a string, but it is a 1 inch. The backslash in this case we'll talk about later, but it's telling me it's 1 inch because I changed the architectural units. So I want 2, which is decimal units, and I want to go through a precision of 3. Now down here, string 2, I'm going to I turned inches already into a string. So let's turn whatever the value in millimeters is into a string. I'll do that. But because it's millimeters, I'm going to say 25.40. 2 decimal places is enough, but I could change that right here as well. So those 2 things right there now become variables, and those variables represent the 2 numbers that I have, and they're both strings. The alert box that I just showed you at the AutoCAD command line, the alert box comes in here, but you can only alert with a single string. Therefore, we have to string concatenate, kind of a weird word. It means to join together as though they are one. An old word, probably Latin is my guess. I should look that up. So what I'm doing is saying let's put together the words value of space ST1, which is going to be in inches, space inches is ST2 millimeters. Now if I do this, come up here, bad argument type, probably because I never ran these lines, right? I never set equal to ST1 and set equal to ST2. So now ST1 is equal to 1.0. It's because when I ran that, I ran it in here instead of running it out here. So now I'm going to set those variables. And if I were to right click on them and put those in my watch window, there's 1. So now that has a value. Now that has a value. Now if I double click this and I come up here, the value of 1 inch is 25.4 millimeters. Well, okay, that's not too exciting because I already knew that. But now we're going to load this whole program, now that we know it runs. By the way, I'm trying to show you the way you troubleshoot your program is you go through one line at a time to make sure each line works. Now I'm going to load that. It gives me a command, I2M. We'll leave that over here. I go back to AutoCAD. I type I2M. Now it says value in inches. I could type 101.23 inches. Bang, it comes up and tells me how many millimeters that is. Puts it in an alert box. Now it doesn't have to go into an alert box. I could have it show up at the command prompt. If I have it show up at the command prompt, then I can copy it. So there might be an advantage to doing that. I could get rid of that altogether. If I got rid of it altogether, it would just duplicate it or just do the math and then put it up here. There's also a way to use that information transparently. Now, if I wanted to expand on that, obviously, the next thing to do would be to write the same thing as an M2I. And I'm going to let you work on that. Otherwise, I mean, you can't obviously multiply by 25.4. You have to divide. But otherwise, it's the same kind of thing. You put a division instead of multiplication. You get the value in millimeters. You divide by 25.4. You do the real to string conversion, put it all together right here. And now with one program, a few modifications, you now have two programs because you're borrowing, i.e. stealing from yourself from another program. That's enough for this video. I'm going to make another one for the next chunk, and I'll have several videos in AutoLISP as we go along.